than a
interesting how
year.
things are going, yeah, moving quickly. So,
Yeah, exactly. No. It's like, I mean, this is, really, I think it's definitely old because this is pre-ChatGPT, right? So, there's a lot of ideas in here that I think are actually really interesting because I'd say they were more well, you'll see, but it's like it was before everybody decided like a next token prediction transformer chat interaction with an agent and a user was definitely how everything was going to be done forever. It was back when they were, just releasing GPTs and saying, okay, what can we do with them? Um, so yeah, the topic is efficient training of language models to fill in the middle, um, or FIM. That's like the general term for this task. So as an introduction, everybody knows that most LLMs autocomplete after whatever you're typing, right? So if you're writing code in your favorite editor, the AI like Copilot will blah 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 suggest the next line of code. You can accept it, reject it by pressing escape, etc. So in somehow GitHub Copilot also will fill in the blanks in the middle of something that you're writing. For example, in this one, there's a function that just is FAB, and somehow it figured out, oh, okay, this is actually what the function does. It returns the greatest common divisor of A and B based on context that's in front of where you're filling it in. So the way that this is done, that this paper proposes, is basically if you have a sentence like the quick brown fox jumps over a lazy dog, then what you want to do is to find examples or to do inference. You take out a chunk in the middle. Like, let's say that you're trying to get a model that will correctly predict. If you say, if you take out the middle here, jumps over, it'll correctly predict that the missing words are jumps over. Um, the way that they train these is basically they split every sample into a prefix section, a middle section, and a suffix section. And then they move the prefix. They keep the prefix at the beginning. They put the suffix afterwards, and then at the end of the sequence, they put the middle section here. So every one of these gray things is like a special token. You might have to add them to your tokenizers, depending on every tokenizer defines them differently. But if you're doing it yourself, you have to actually like come up with one and train it so that it knows that at the end of the mid token, you're supposed to put in words that would go right here, right? So in practice, yeah, this is basically the same thing. In practice, you train a sentence like this: beginning of sequence, FIM start, quick brown fox, FIM hole, the lazy dog, FIM end, jumps over, end of sequence. And then when you're doing inference, you do the same thing, but you leave off the last part and let it complete and then say end of sequence. And that's how you know it's done. These token names, as you can see, they're totally different and they're taken from DeepSeek Coder V2. This is the paper again. This is like the abstract, but I have some really interesting points that they make in this. Number one is the FIM for free principle. What they say in this, again, this is 2022. What they say in this is that based on this paper's results for a couple different model sizes, FIM as part of the training regimen does not degrade non-FIM quality outputs. Uh, so theoretically, um, every model could be trained to be an FIM model with little cost, is one of the main conclusions of this paper. Um, Number two is description of exactly how you do best practices for FIM and pre-training. Number three is fine-tuning inefficiency. They basically found its performance is a lot worse if you fine-tune as opposed to including FIM and pre-training. There's some theories about this. Yeah, there's still like properly initializing a new token is actually like um, kind of an ongoing discussion, and definitely there are improvements in that since 2022. I would argue that might be a big part of it because, in my experience, fine tuning is not as bad as what they say. But yeah, this and the bullet point one leads to the interesting idea that all models should be, not just can be, but should be trained on FIM examples during pre-training. Number four is that they happen to choose code as a test case just because it's easy to eval code because it compiles and you can see if the code runs and if the answer was correct. Five is just more benchmarks are needed. Test loss is not a great indicator. Anyway, these are what they say are the main points of this paper.
Yes.
But yeah, I'd say these. Yeah, go ahead.
I don't know. I've never been on this before, so if the questions are for the end, that's fine. Just let me know.
Okay, that's okay.
One is, how do they calculate what is in the middle? Is it just a word count and then take the middle of that, or is it just a rule-based thing, or how do they figure that out?
Yeah, you basically want a lot of variety, but for them, they want to uh, have a lot of text in the middle. So uh, it's, I mean, what I found is that varying the length of the middle segment, the before and after, is helpful to just make it more robust, basically.
Okay.
So you theoretically could get it to always. Yeah, when I was doing one of these, I had, and these are like on small models, but when I was doing one of these, I had an issue where my training samples were all like 250 words, and then 3 words in the middle were taken out. Um, and that worked great uh, until you gave it a prompt that was like, uh, so the prompt would basically be like some tokens and some like special tokens and 247 words. And if you gave it like 250 words, then it would say, well, there's already 250 words. And I know that 250 is the right number. So I'm not going to add any more. That was like an issue I got, was that if you don't have like a lot of variety in the spacing, then the model will like really learn the wrong lesson, which is that you're just supposed to fill it in until there's like a certain number of words, for example. Um,
That's interesting.
I think, yeah. So you want like big sections, short sections, but because what they did a lot of the time was like leak code problems and Python problems. They imagine like a leak code answer for like reversing a linked list or something like that, and that's like maybe a normal sample, and then you take out maybe like 50% of the middle or something like that, maybe 25%, and that's what they trained a lot of those on.
And
um
is this at all connected with? I know that there's an issue with what's it, man in the middle kind of thing, where basically if you have uh too much um where yeah, right, the where the length is too much basically, and then there's too much between, it's too long, then it has
yeah.
difficulty with that. Is that related to this at all, or is that something different?
Okay, well, basically the yeah, this is jumping ahead, I guess, but
I'm sorry.
the
You
real
can get to it later. It's
difficulty.
fine.
No, it's okay. I mean, I'm not sure I entirely go into this, but the real difficulty that these models have a lot of the time is not going off of. Okay, so if we go back here, you can see like it has like the start and then the end and then the middle, and a lot of the time, especially like when you're starting training, it's used to text that's like this. It's used to text that goes left to right, and so it just will kind of think that it's like a weird sentence, and it'll just try to continue it and ignore the tokens. And really, the difficulty after that is like once you get it to understand, like, okay, you're like filling in the middle. It is pretty good at continuing after, for example, the green part, like the prefix. But it takes a while for it to figure out, like, oh, and also I have to end up here, right? So I'd say there's like, from what I saw, there's like 3 stages of learning. The first is it doesn't understand the task. The second is that it is trying to, it does a good job of finishing of like continuing the prefix, and then the third is that it actually connects it to the suffix. Um, that gets harder the longer the thing you're inserting is. So
Yeah, that makes
I
sense.
hope
Thanks.
that's related.
Yeah.
Yeah. Um, but yeah, as I was saying, basically the conclusion of this paper, which papers, right? But the conclusion of this paper is that every model should train on FIM during pre-training. So every model can theoretically do just as good if it has FIM capabilities or not. This is really not what happened. We'll get into that more later, but it's just interesting to hear them say that. This is their example of how if you have even 90% FIM prompts, then the performance of the model doesn't noticeably decrease um, until you get to literally everything for non-FIM tests. It doesn't decrease until you get to a 100% FIM rating in which it like overfits on everything naturally must be FIM. It kind of makes sense, right? But most of what it's doing is like next token prediction based on a bunch of words behind it. So it kind of makes sense that it would still be able to do a lot, even if the words were all switched around, especially on really big samples, like hundreds of words, thousands, that sort of thing. Yeah, so as I was saying, they even suggest training on multiple orderings, which nobody does. I'll say that Mistral in CodeStrel did this, and they actually do suffix, prefix, and then middle. And this is, I think, to kind of overcorrect for, well, the quick brown fox jumps over should follow logically, and then we can try to make it so the model like loops back around to the beginning. Nobody does this now, and I was looking around. They actually like don't have a separating token between the prefix and the middle part. They only have the in the first version of CodeStrel, they only have like a separating token for the suffix. And people just if you look at what people on like Hugging Face say about the model, they say it's a bug, not like an intentional training strategy. So I thought it was too until I read this paper and I realized, oh, this is actually like something that they thought had some value at the time, but it's pretty much abandoned now. They say this is another point they make is that character level splits are really important. I think this essentially is pretty intuitive once you think about it. If you're infilling code, for example, there's going to be a lot of tokens like def or import or maybe like for I in. And if you're writing Microsoft Copilot, then people are going to get like halfway through an import statement and then they're going to be like, wait, what am I importing? And so you need to train to make sure that that happens a lot. So you need to like split up a lot of your really common tokens, especially in code where people end up writing the same exact word like many times. So yeah, they found that the random span infilling was really terrible if you did line level random spans. I don't know. I think this is pretty intuitive on its face. Yeah, this this was an interesting diagram. Just a visual representation of like what it's trying to do, right? It's essentially moving the middle to earlier on, and then showing that you have this like break in the what's it called? You have this break in the traditional shape of like how attention is going to be distributed over time. Some other notes. They almost never mention positional embeddings, which is, I think, really interesting. This is, I guess, probably a hot take, but I think obviously attention is all you need is like most important paper. You know, I could be really extreme with this, but it's an insanely important paper. I think among the new concepts that were introduced in the paper, maybe positional embeddings are the one that at least gets questioned the most, although it's still obviously ubiquitous. But I just thought it was interesting that they just like did not even consider, well, what if we just moved around the positional embeddings and tried to work with that. So going on to like what ended up coming after this paper, like I said, primary outcome of this paper was widespread creation of FIM models just for coding, whereas essentially nobody does natural language FIM, um, which is kind of interesting because I think this is definitely a case where the eval capabilities of the data set led to um, model development and the direction that people created new models in. Obviously, code is easier to evaluate because there's pretty much one correct way to do things. You can also have it compile and give the correct answer or the incorrect answer. So it's very objective. So as of right now, the state of the art code FIM model, from what I've read, is DeepSeek Coder V2, which is built on top of DeepSeek LLM V2, which is a really large mixture of experts model.
Sorry, Nick.
They,
Interject there.
yeah,
So are you saying that um, because they did it on code,
yeah,
that basically and we don't do this on natural language, that it sort of led them in a direction um, that was like if they had done it on a more by diverse um, set, would have given them a different perspective.
yeah. I go into that in the next slide.
Oh, okay. Sorry.
I have like, I don't know. I do think it's like, it's probably like the most interesting part, I guess, to me, because I guess um, I already sort of knew that FIM was mostly coding, but yeah. Uh, oh, okay. I guess this is like a sidebar. I'll go through this quickly. DeepSeek Coder and DeepSeek LLM V2 actually used what is it? GRPO. I forget what it's called. It's group something. Uh, the thing that they were doing for R1, but it was already used in DeepSeek Coder V2. Um, and then when I looked into the DeepSeek Coder paper, I found that I really would say, even though people don't have as much hype around these models anymore, coding is really far from being solved. For example, the live code bench hard problems, like at the time, the absolute best any of these models could do is 6% from GPT-4 Turbo, um, which is not an FIM model. So that's why this is still the best FIM model. Um, Nowadays, I'm guessing O3 is probably the best as far as non-FIM models.
Could you
Anyway, as far as yeah, go ahead.
elaborate on what those numbers represent?
Just like successful coding challenges for this benchmark. It's like very hard, like leak code style problems.
So it means it compiles and runs, even if it wasn't necessarily the same um, text.
Yeah, I think so. Yeah, and I think it's like it. Yeah, it probably like needs to clear all the corner cases as well. I don't know. I could look into it certainly, but I just thought it was like I don't know. My impression, honestly, is that like um, uh, when you see the especially the reasoning models, you think like, oh, like people can kind of solve anything with this. And I was surprised to see that in 2024 at least there was this whole benchmark where it was like nobody could get higher than like 6%. Anyway, I don't know. It's kind of out of date anyway, but
You say no one,
yeah.
you mean the
So
models
for
can, that's how well the models could do on these harder problems.
exactly, yeah, yes.
And is that more um, a result of the training set where basically the training was more done on your normal, like your basic or your common type of problems, but not as much as the hard ones? Or is that more in terms of the logic that has to go through in order to solve a hard problem is more complex and therefore the models doesn't come up to speed on that?
Yeah, that's a good question. I don't know. I'd have to look into it more to find out. Yeah, I don't know. It is a good question. Um, okay. I'm going to move on here. As far as FIM with natural language, yeah, like I said, nobody trains their models on this based on this concept of like FIM is free. Uh, even though this paper came out of OpenAI, I don't know. It's kind of interesting because, among other things, people might just be leaving functionality on the table and not claiming it because this isn't the trend the industry is going. I really don't know, what the cause of this is. If I had to guess, I would say probably people have tried it out a few times and found that there's some sort of marginal decrease in performance, and we're told, okay, why are we doing this? That would be my guess. But I would say as a result, like natural language completion in applications is like pretty naive, I would say. Like if you're in Gmail, Google Docs, text messages and stuff, it's still kind of just like the simplest version. These 10-year-old algorithms a lot of the time. This is also, probably out of date because now Apple has a lot more AI chips on their iPhones and small models that can work. But I don't know. It's interesting that the industry just went really hard in the direction of chat back and forth interactions, and kind of abandoned this idea of like filling in the middle as natural language. Possibly because, among other reasons, you can sort of just prompt this. You can say, here's the, you can say to ChatGPT, like, here's an essay, there's a missing paragraph here, fill it in, and it will do it, right? Like, that's kind of a thing that keeps coming up when I'm working on similar projects, is that I keep thinking, okay, is this really that different from prompting? It's like, yeah, you have these tokens, you're training it to do this specific thing, but you also can just prompt these models to do this task anyway, right? So I think that's probably the primary reason that people haven't followed up on this very much, except for code where it's a lot more efficient to have Google or GitHub Copilot fill in the rest of the function for you, like as you're typing it, right? So speed matters, and being able to do like medium quality auto completion within a larger body of text is like a lot of what you want there. That's it. That's all I had on this. But yeah, any questions?
I don't have a question, but I was just thinking that also part of I'm wondering if you mentioned basically this focus on chat versus FIM. I wonder if part of that is a like business marketing thing, because if you think about like how do you get to the most people, and how do you get people excited about technology? It's probably not FIM, it's more chat, because people are not necessarily, the vast majority of people are not doing coding, and therefore the fact that they
Yeah.
can chat with something, and that and everyone can do that, it's a much a larger audience, and you can get an amazing uptake, which is what they did. And they wouldn't probably have gotten that with doing it with FIM as far versus the chat. I don't know. It's a
Yeah.
non-technical whatever, but that's yeah.
Well, so much of it is also based on the idea that you want your AI to be a helpful um, AI assistant, right? Like that's why they make it do that, is because they want to they want to try to create a product that is helpful and waits for your command, right? And I don't know if you guys feel the same way about this, but like as soon as I install Gmail on a new computer and I see that it's like auto completing words for me, I have to Google like, how do I turn this off right now? Because it drives me insane. I like, you know, half the time it's like, I start writing the letters like PR. And it's like, I bet you're typing the word probably. I'm like, yes, I am, but I didn't ask you, like always gets me like really mad, like I don't know. I think that especially in an essay, I also think it would be like if they just do it without prompting you, it would I think that would drive me insane, right? Like if it was just like, well, it looks like you're writing like an essay. How about I just finish that for you? It's like it's very pushy, right?
Might just
Whereas
be
in code, I think it's different.
a failure of personalization. I appreciate it. So, but it should know
Yeah.
you don't appreciate it, and that I do, and treat us differently. So,
But I mean,
I
I
mean,
can see
there's
like
just like a lot of
if you're trying to be
fear,
like
uncertainty, and doubt around like the field, right? So like I think that a chat interface where it's like, please do this, like you're sort of, I guess, getting people to think about the model as something that does something at your command, as opposed to something that is like trying to get you to do something in a certain way that it likes or something, right? So
yeah, because if you're trying to be like more like you're writing it now, say you want to be, you're thinking, okay, you try and get your thoughts together and you're being like, you want to be individually sort of creative and individually thinking about it, not like, giving that over to the computer, then I could see where that would be, annoying. Now, if you get stumped or whatever and you want some ideas, that's a different story. If you want to finish, you want to write a draft and then you have, like you say, okay, what do you think about this? And then, something like that. But I think I can see that in terms of, like I just want to think. I just want to basically give me quiet, let me focus, and let me, try to get this thing done.
yeah, yeah, and I think yeah. The other thing I think about is like I said, the more I work on this problem, like when I was working on this problem at first, I kept having this feeling of like, you know, if you can complete the end of something and complete the middle of something, this is a totally undiscovered field, within the field. Like this is a totally undiscovered area within the field of like transformers and LLMs and stuff. It's untouched, nobody's doing anything about it. And then the more I thought about it, the more I realized like, well, filling in a section of text is a really specific use case, actually. And it's much more common, for example, for people to just say like, can you make this paragraph sound nicer? Or can you make it sound more professional? Or can you fix my grammar mistakes or something like that? Every one of those is like a separate, you could train a whole model on that task, but you could also just prompt it, which is kind of like the issue with a lot of these things is that
from a more like product business type perspective, I've encountered quite a bit of the problem where you want to keep a portion of text unchanged, but change a portion of text. So you want to keep the what's before it unchanged and what's after it unchanged, which provides the
yeah,
context. And before I was aware of the fill in the middle concept, I called it textual inpainting and was trying to find out how do you do textual inpainting, which is fill in the middle.
yeah.
But does that use case seem as prominent to you as it has to me, or do you
I
dispute?
guess I would say if I ever talk with anybody who is not in tech about ChatGPT, they always say I use it to proofread. Like that's by far the most common thing that I hear people say. But or to write the whole thing from the beginning, which neither of those are fill in the middle, right? Also, I think the other thing that's funny about it is that okay, here's another. We're just talking about product, I guess, like product viability of this task. The one thing that you don't really want to do in the vast majority of cases is like you have an essay. Let's say you're like writing a letter or something, and there's stuff that's before and there's stuff that's after, and you're like, can you fill in the spot in the middle with just the stuff I've already said? Just like repeat it again. Be like, remember earlier when I said salutations? Well, it really is really good to talk to you. It's like it's
But
useless, right? Like,
not necessarily writing from scratch. Let's say you already have a paragraph in the middle and need to update it because new information has come into the system.
right, but that is different, right? That's not a completely like auto completing the middle. It's actually like that's a more complicated thing that you can do with prompting, but you can't
I was gonna
do
say
with
you would
fill
do
in the
that
middle
with yeah,
because
you could say here's the, prompt where like here's the old version, and now here's the new data. Please integrate that with the, this
Yeah.
letter. And then you basically, like that's more of a prompt than a fill in the middle, I would think.
Yeah. I think that improve the middle might even have more product viability than fill in the middle for natural language, at least, because I think that's a lot of the time what people want is they're like, this part is not great. Can you make it longer? Can you make it sound better? Can you make it more professional? That sort of thing. But they don't want to just fill it out, right? They want to improve what they have a lot of the time. So
And that would be
I
a
guess I
problem,
sort of
right?
talked myself into this being like useless. I don't know over the course of this call.
You would basically put your, your old essay in and you say, even if you have a specific thing you want to, paragraph two, I don't think that sounds great. You would put that in, right? And then say, now, please, as a, helpful, editor or whatever, show me how you would improve, paragraph two or three or whatever.
Yeah,
But I would
yeah,
point out that pretty much the whole concept of this fill in the middle paper can be boiled down to just you have one special unique token in the case of the Mistral example. I guess a couple more in the more common example. And this token provides some additional information.
yeah. Which is also, I don't know, that to me goes back to like, what happened to positional embeddings? Like, why aren't we just saying like, here's a bunch of words that have their own positional embeddings. Now here's some empty tokens that have these positional embeddings. Go fill them out. Because like, I don't know, they're not as useful as we think they would be. Like just having one token and then training on that token and the associated attention with it for
That was going to be a question I was going to
million
ask, is
GPU cores.
how does the size of um the context window change how you use the model and performance?
Yeah, I think I would need to go more into the coding examples and papers to find that out. But that's one where people are always talking about um, how the context window for Gemini or Copilot or whatever is like bigger and bigger. Um, right.
You definitely have a lot of knowledge of this question Frank asked. Do you want to comment on that?
Yeah, yeah. What is this? What is this exclusively just for text? Maybe audio or images would benefit from this. Improve the middle concept. Yeah, I mean, me and Julian, I guess, can speak to images. In painting is like a big thing in images, but it's terrible actually because like it's really hard to get a good in painting model because you kind of want to. It's actually very similar. You need to train the model from the beginning as like an in painting model that has uh, blank areas that you're filling in. Um, and train it on that in the pre-training stages. People try to add stuff on to existing models later that turns them into in painting models, and it always is pretty unsatisfying, honestly. I mean, I don't know. There's like decent ones, but it's very hard to get those to work. And then for audio, I've also been looking into audio stuff a lot recently. It's like a total diversion, but there's like a bunch of really good text to speech models that have come out in the last like month, and like some of them have like the Apache license, like you can just run it in a commercial application and it's fine, which is crazy. But the way that those work is they have phoneme tokenizers, so it's pretty much the same as a text tokenizer, but for types like sub parts of a word. And one of the models, yeah, for a lot of the models, you need a big data set of text and associated words, but want um, you want to have a good phoneme tokenizer, and there's kind of like the best phoneme tokenizer that exists right now is in English, and there's a really good one in Chinese as well. But it's kind of like how you have to have a good VAE to make a good image model on top of it, I guess, or figure out like what the correct compression for that should be. But yeah, that's like actually something that's hindering a lot of audio models because audio is like kind of behind the other areas right now.
So I was thinking,
Um,
maybe like, is there like a way, like how there's like that fill and like improve? What if there's like a weakness, sort of like saying, you know what, like this essay, like these parts are not good, right? Is there such a
yeah.
thing like that? Oh,
Okay.
okay.
This is like completely separate thing, but like
Up there, up. Okay.
I want a product from like OpenAI or Anthropic or something where it's like a diff for my written stuff. Because every time I talk to one of these things, they say, I'm like, can you improve it in this way? And then it's like, it's basically its own essay about how it's
Mhm.
improved your essay, right? Like they say like, well, I generally did this. I generally made it more professional sounding by removing references to this kind of topic repeatedly. And then it'll have like a few examples, but then it just gives you the whole thing again. And for me, I really want to
Right, you
like
sort of like
a
want
diff
like
interface.
like the red line or whatever, and basically you want, or
Yeah.
like you want to basically say, like, here to get rid of, change this to this word and put this there, and like this is, oh, that's interesting.
Yeah. Because I am always too scared to just be like, can you, this like, I don't
Oh, I
know,
see.
this
Yeah,
letter
there's
to like
an
my
aspect, a
lawyer,
positive
can
aspect of
you
the
like
diff
make it
is
better?
that you can basically, you don't need to trust the the model. You
The
can actually
entire thing,
see
right? Yeah.
exactly what it did, and then
Yeah.
determine whether you want to accept those changes or not.
Yeah. Yeah, exactly. That's what I always like I really want one of those. But
Does that.
yeah.
I just
Um
presented a paper that used special tokens, right? Or am I mixing up which paper you presented? Edison?
Can you hear me now?
Yeah.
Uh, I don't think I did. Did I? Let me go back to my papers. I don't think I did. I think mine were just the only tricks they used were in like the post tokenization processing. Right? Yeah.
Nick, do you have any broader thoughts on the idea of special
Yeah,
tokens?
I thought it's interesting. My only point would be like I don't know. I thought I was talking earlier. Um, was it like why kind of in a sense train on this why do like improvement in the middle when you just improve all the text, although it could be interesting to be like, oh, I know I don't want to change um some of this, so like, but I don't know, maybe you could say, oh, well, that should just come on the prompt as like actual worded tokens, but it could be interesting to be like, well, no, we could like, because then you like this the opportunity to say, okay, well, if we see this token, then if we know that we have weights that are somehow going to affect something later on, it's a very good catch-all.
if I
Anyway,
was to like yeah, if I was to say like I don't know, going back to like why do it, like why is this important? Um I think it's also one of the examples, like the coding thing. I think in general, fill in the middle tasks are probably inspired by like Word to Vec and stuff, where
mhm.
a lot of the big innovations at the beginning of um, large language models or like small large language models like
Yeah.
BERT and stuff was because you could you could just get a ton of stuff and then just like poke holes into it and say fill in the hole,
Yeah.
and then boom, there's your amazing data set. You have the answer and then you have the problem for it by just like doing that on trillions of articles or whatever, right? And so I think that might have been the inspiration, is like the data is incredibly easy to get and you know for sure that it is good, right? Because all it's doing is just filling in whatever it's supposed to, like whatever was there before, right? So I think that might have been part of the appeal of like why do it in the first place, which is kind of another interesting example of how just what data people have access to ends up driving the direction of these models a lot of the time, as opposed to like I want a model that does this like product wise. It's kind of the other way around. It's like we've got all this data, it's really easy to use, and we've got $500 million to spend on GPUs. So let's just run it. Maybe it'll magically be really good at some task.
Yeah, yeah.
I guess on a related note, or maybe if it is or not, if not, I can take it off. I can take it offline. The I think I hope I get this correct, but the focus has been more on what's it? The decoder, correct? There's encoder and decoder. And so, but the encoder is more focused on the context than the decoder, is my recollection. Um, and so, assuming that's correct, and if it's not, educate me, or tell me where my hole in is what I'm saying is, um, because you have those models like what's it the T that combines the encoder and decoder, but the GPTs are more like the decoder,
Yeah.
only.
Yes.
Is there, you know, a is that be is there a reason why that we've gone more, decoder, or and is that is that the correct, like, best, approach? But this is going a little bit off topic, so I'm happy to take it
Yeah.
offline. That's not relevant to the conversation.
I have like a guess, but maybe somebody else wants to take it. Honestly, I am not very confident. Anybody? No.
Repeat the question. I apologize.
It's
So
like why are models so decoder only, or why is decoder only more common now than like an encoder, which theoretically could absorb a lot of the context?
Oh, what is your hypothesis?
I guess I would say like
Honestly.
decoder, like um, that a lot of the benchmarks and a lot of the tasks that people are trying to do is based on basically there were more improvements as you focus more on the decoder because um, you can only absorb the context and get so much information in like a latent space. Whereas if you're doing a multi-step process, then you can look at previous steps in the process and think about them really hard. And if you focus on those more, then you can be good. You can be better at making like a longer multi-step process, which I think aligns with like, for example, reasoning models where they just think about it for like thousands of tokens. And then they tell you, there's 3 R's in strawberry or whatever, right? It's like the chain of thought, like the thinking about the process like over and over, and like doing that is like how you think about something harder as opposed to like how you observe something only.
mm.
And yeah, that would be my theory, I guess.
So that's kind of like, if I'm thinking about it in common terms, it's more like a seeing it like one time kind of thing, or seeing it like, and then like seeing the whole thing and then coming up with it, versus thinking about deeply, pieces of it and then
Yep.
putting it together.
Yeah. And I think like the idea of like we just need to cram more information from the observed context in, and then like basically like funneling stuff in is like why RNNs are not as useful anymore, right? Is because they have this like bottleneck where there's a certain point where they like lose the where they where all the information has to be like crammed into one spot, and then it like finishes the topic, right? I think that like if you focus more on like the things that happen after your first observation and then like what you've already been doing more, then that's like more aligned with the tasks that we give these models, which is like these hard problem benchmark things to get them to think harder.
And
I
just
don't know.
and one more follow-up on
Again,
that is are the benchmarks driving things too much? Are the nature of the benchmark problems, is that, it's something to hang your hat on and something that, they'll be evaluated on. But is that sort of we're getting are we getting so caught up on that we're not seeing the forest of the trees in terms of,
that's like I think that's a really big conversation, right?
yeah,
I
okay.
don't know. I think so, but I don't know. I guess that's all I have to say about it, basically. Like, I think probably. Um, I don't know. Uh, yeah. Um, yeah. I don't know. Like, everybody made this big deal about the reasoning models and how they actually can solve a bunch of benchmark problems. I don't know. I don't really use them personally. Like, I still just use my, like, cheap Claude subscription, and it's pretty good. Like, most things you need an LLM for are like not actually these really hard problems. Um, I don't know. It's because they're driving towards AGI, right? Not driving towards like a good product. So for them, I think it's valuable. But
But
for
yeah,
me,
like
it's
that's
not.
an interesting from a like a business plan perspective, right? Does AGI really help you like build something that can basically be a solution for someone for
Yeah,
a
yeah.
specific thing, right? Because it's
It
trying to
reminds
like
me of like, yeah, like I think it was like Microsoft told OpenAI, you can say you've achieved AGI when you make a product that makes, what is it, $50 billion or something like that. Like they just said like if you're making AGI, then how about you tell it to make some money? Then you can say you've made AGI. It's like like in a way, I use proxy, like I use a good product as a proxy for like the smartest thing to do, right? But you know, right now they're trying to make the smartest thing possible by giving it the hardest problems, and then eventually they're going to use that to make a good product, right? But it's like this sort of roundabout way to do the same thing. I don't know.
right. Why don't you just look at like the low-hanging fruit and looking at the problems that people are having, and then,
Yeah,
focus on, that, and then in terms of the latency and cost, because that's practically speaking what is going to be more, you know, um, that's going to help develop, a marketable and profitable product. I mean, I understand from the research standpoint that's not like what their focus is, but rubber hits the road.
yeah,
That's what, you know.
yeah, yeah. I think it's yeah. I think it's just basically like they don't like. It's hard to know how to make a problem that's so hard that you can't solve it, right? So that's inherently like a kind of a mind bending problem. So yeah. Okay. Anything else? Any other questions people had about
Looking at
if there's
into
anything?
description.
Yeah, it's fun topic, like fun discussion, definitely. But
Any last questions? Rohan, do you have any updates on your presentation? Otherwise, I might be the one presenting next week. Cool. Well, yeah, hopefully everyone learned something, and look forward to the topic next week. So, yeah, thanks, Nick, and thanks,
all right,
everyone.
great.
Thank you so much, Megan.
Yeah,
I hope I
thanks,
didn't ask
Julian.
too many questions that it was just very interesting to me. So I appreciate it. Thank you.
Yeah, thanks, Rohan, also. And thanks, Jeffrey. All right, great. See you next week.
Later.
Bye.